Okay, today we're continuing with Chapter 4. We're actually going to finish up 4.2b, which is linear equations in one variable. So yesterday, the last time I saw you, we talked about solving linear equations, and today we're going to solve linear equations, but this time those equations are going to contain fractions. And the most important thing that you want to remember about that is that we're going to multiply both sides of the equation by the LCD, least common denominator, to eliminate the fractions in our equation. And then it's just like what we did yesterday. We're also going to talk about those equations that have no solution or infinitely many solutions. So let's do an example with fractions. Here's our equation, 3x over 2 equals 8x over 5 minus 4. Okay, we're going to multiply each side by the LCD. So you're looking at 2 and 5. The least common denominator, because they have no common factors, is 2 times 5, which is 10. So I'm going to multiply both sides by 10. Notice that you need to put your parentheses because you're going to have to distribute the 10 over any term on that side of the equation. This side only had one term, this side has 2. So then to remove that parentheses, we just show 10 being multiplied by every term. And keep in mind, the reason we're doing this is to get rid of the fractions because 2 goes into 10 and 5 goes into 10. 2 goes into 10 5 times. 5 goes into 10 2 times. So then our next equation is not going to have any fractions. It's going to say 5 times 3x, which is 15x, equals 2 times 8x, which is 16x, and then minus 40. So now we have taken this equation and removed the fractions. Then it's just like what we did before. So we have our equation. We're going to collect the variables on one side, and whenever you're moving things from one side to the other, it's addition or subtraction. So we're going to collect the variables. That means we're going to subtract 16x from both sides, and that's going to leave us with negative x equals negative 40. Okay, so we have our variables on one side, our constants on the other. I haven't solved for x if it says negative x, so I'm going to divide both sides by negative 1, and then I'm going to get an answer of x equal to 40. Now remember, you can check your answer. Take this equation, and wherever you see x, we're going to put 40, so it'll look like that. Then you're going to put this in your calculator and get a number, and you're going to put that in your calculator and get a number. And as long as those two numbers are the same, you know that your answer is x equal to 40 and your answer is correct. Okay, let's go do one more of those. We have 7 halves equals 1/9 x plus 26. So it looks a little different because the x is not actually in the numerator, but it still has fractions with our, especially with our variable. So we're going to find the LCD between 2 and 9. Hopefully you know that it is 18. So we're showing that distributing, and then I'm going to write 18 in front of every term of my equation. And then, how many times does 2 go into 18? 9 times. 9 into 18 goes 2 times. So again, I'm getting rid of my fractions. 9 times 7 is 63. 2 times 1x, 2x. 2 times 26 is 52. So to collect my variables, I'm going to, hopefully you can see, I need to move the constant over here. So this time we're going to subtract 52 from both sides, and that gives me 11 equal to 2x. So I have all my variables on one side, my constants on the other. So this time I'm going to multiply or divide, and I'm going to divide both sides by 2, and I'm going to get an answer of x equals 11 halves. Again, to check it, I'm going to put 11 halves in where I see x. So that's going to look like this. 7 halves equals 1/9. Again, parentheses whenever you plug something in the equation just helps you be able to see how it relates to the original one. Don't have to put that in, but I put this in my calculator and find out that it equals 7 halves. So I know that my answer was correct, and that answer is x equals 11 halves. Okay. The next time we need to look at some unusual cases with equations. So I have an equation that looks like this. 2x plus 6 equals 2 times the quantity of x plus 4. So the first thing I have to do is to remove the parentheses and multiply 2 times x and 2 times 4 to give me 8. And then I'm going to collect my variables, so I'm going to subtract 2x from both sides, and that's going to leave me with 6 equals 8. Well, surely each of you knows that 6 equal to 8 is a false statement. Therefore, this equation has no solution. The solution set is this symbol, which refers to the empty set. That's called the null set. So when you come down to that, if you will please write the word false next to it, and then in your answer blank, you can either write no solution or you can use that symbol. And the other special case that we have is one where we will have no solution. Actually, not no solution, that's what we just did. Look at this one, we'll see what happens. So we have 4x plus 6 equals 6 times the quantity of x plus 1 minus 2x. So I'm going to have to distribute the 6, which is going to give me 6x plus 6, and I carried everything else down. Now I have two variables on one side here, so I'm going to combine those. This side won't change. 6x minus 2x is 4x. So I carried everything else that I didn't combine together. Now, you can leave it like that if you can see it, or you can go ahead and collect your variables again, and you will come down to yet another statement. This time our statement is true. And again, you can write true right here if you can see those are exactly the same. But whenever you get the exact same thing on both sides, that particular equation has infinitely many solutions, and the solution is the set of all real numbers. And what that means is it doesn't matter what number I put in here, it's going to come out true. So that's how you answer those questions. If you have any questions when you're working, I encourage you to check your answers. Then you'll know when it comes time to the test whether or not you're doing things correctly. Let me know if you have any questions.